Our names are Emilio and Indy, and we are future graduates from one of America's top physics schools. Now, we are using our knowledge to help Hollywood make better sci-fi movies. This is Physics for You. Over the years, Hollywood has co-opted concepts from physics to make extravagant and excellent movies that make millions of dollars and also get millions of people intrigued in learning more about physics. However, very rarely do TV shows and movies actually explain the physics that's happening in them. Today, we'll be talking about Interstellar, the 2014 blockbuster hit written by Christopher Nolan, and rate how well it did in explaining the physics to its audience. Interstellar takes place at the beginning of a climate change apocalypse, where our protagonists have to travel the cosmos in order to find a planet suitable for life in order to save life back on Earth. One of these viable planets creates a sense of looming anxiety among the crew as well as the audience. Time on this planet moves much slower when compared to Earth. This creates a high-stakes mission where our crew directly experiences a relativistic phenomenon known as time dilation due to the massive black hole that the planet orbits. The consequences of the geometry of space-time. Let's look at how Interstellar explains this puzzling concept.
Taylor still looks good, though, right? Because she's coming up fast. With one complication. The planet is much closer to Gargantua than we thought.
Gargantua. It's what we're calling them, the black hole. Miller's and Dr. Mann's planets both orbit it.
And Miller's is on the horizon?
Oh, it's a basketball around a hoop. Landing there takes us dangerously close, and a black hole that big has a huge gravitational pull.
Look, I could swing around that neutron star to
No,
decelerate.
it's not that. It's time. The gravity on that planet will slow our clock compared to Earth's drastically.
Oh, how bad?
Well, every hour we spend on that planet will be 7 years back on Earth. Well, that's relativity, folks.
That's it. Now obviously, that was not a good explanation, but that's okay. Here's how we think it should have been done.
But Miller's planet still looks good, with one little complication. The planet is much closer to Gargantua than we thought.
Gargantua?
It's what we're calling the black hole Miller's planet is orbiting. It's on the horizon, and a black hole that big has a huge gravitational pull. Gravity on that planet will slow down our clock compared to Earth's drastically. So much so that every hour we spend there is 7 years back on Earth. That's relativity, folks.
But why though?
It's kind of a long story.
Yeah, I guess we really don't have time.
Yeah, we really don't.
I kind of really want to know though.
So let's say you have two people on a rocket ship, Deirdre and Pablo. And
Who's Deirdre and Pablo?
I don't even know. Let's just call them Devin and Patty. So say Devin and Patty are on a rocket ship of length h, and they're in space, so there's no gravity, and the rocket ship is accelerating at an acceleration of 9.8 meters per second squared. Now say that Devin is shooting a light beam towards Patty every 5 seconds. Now, since Patty is accelerating towards Devin, then Patty is catching up towards the light beams faster and faster. And so she's receiving them at a faster rate than Devin is emitting them. So as you can see, there will be a difference in the rate at which a signal is emitted and the rate at which a signal is received if the gravitational potential between the 2 points is different.
Okay, but what does this have to do with time dilation and Gargantua?
Good question. The first thing we should realize is that clocks tick at a certain rate, and so does your heart. So in a way, your heart is a kind of clock. Now, because we're so close to Gargantua, then our gravitational potential will be small compared to someone on Earth. The same way that someone close to the ground has a smaller gravitational potential compared to someone up in the sky, far away from the center of the Earth. So if we take someone on Earth whose heart rate is 60 beats per minute, measured by someone near Gargantua, that person's heart will beat more than 60 times per minute by a factor of 1 plus phi a minus phi b over c squared. And not only will their heart beat faster, but all their biological processes will occur faster. All the cell signaling that happens between cells and within a cell will occur at a faster rate. And so that's why that person on Earth ages differently. And that's why there's time dilation.
All right, all right, all right.